All right, here we're continuing our algebra review, and we're looking at section A.3 or AR.3. So our learning targets today, first we're going to recognize monomials, then we're going to be looking at some polynomials. I want to know some formulas for some special products when I'm multiplying, right, because product is multiplying. Just looking at them and being able to tell what they're going to be. And then we're going to be dividing some polynomials using long division. We're going to be factoring, and you've done this pretty often. And then we're going to look at some completing the square. So first off, looking at monomials. So a monomial in one variable is the product of a constant, and our constants are kind of my ABC, and a variable raised to a non-negative integer power. So it looks just like a single term. K is greater than or equal to 0, and then we can look at the degree of that. Okay, so here are some examples. So my monomial would be 6x squared. The coefficient is always the number with that, and then the degree is going to be that exponent. Okay, so I can see a lot of these things. So 3, you'll notice, is actually still a monomial with a coefficient of 3. My degree is 0 because anything to the 0 is 1. So I can still say that this is 3x to the 0 because that will still give me 3. Okay. So just looking at these couple things. So 3x to the 1/2 is not a monomial, right? Since this x has an exponent that's not a whole number, not a counting number, it's a 1/2. So I know that that's not a non-negative integer. So I know it's not a monomial. Again, here I have a negative, and I see that that's also not a non-negative integer. So again, not a monomial. So looking at some polynomials. So polynomial has several different terms. That's really what we're looking at. It's made up of several monomials all put together. So here are some examples. So my first one, negative x cubed plus 4x squared minus 6x plus 2. You see I have many different coefficients, and I generally want to write these in the order that I go, right? So from greatest exponent to least. So my coefficients from greatest exponent to least. My degree is going to be the highest exponent that I have in my entire polynomial. So here are just a couple of examples, and they kind of walk you through them. So some special products. We don't use this word in my classroom. It's a bad word because it teaches us really bad habits, and it doesn't often work. So when we have two polynomials that we're multiplying, I always want to take this first term in my first polynomial, which here is x, and multiply it by everything in my second. So then I take my second term in my first polynomial, and again I multiply it by everything. So now I can simplify. So I have x times x is x squared. X times 3 is 3x. Negative 3 times x is a negative 3x. Negative 3 times 3 is negative 9. So now I can simplify this and end up with x squared minus 9. Okay, so that's kind of always what we're going to do if we have two different polynomials. So here I see I have an addition, right? I'm adding two terms together, but I'm squaring that. I cannot just take this exponent and square each term. That is not mathematically how we do things. So what I can do is I know I can always take this first term and square it, and the second term and square it, and I know that those will be my first and last terms when I've finally simplified. And then to find my middle term, I take 2, and then I multiply my 2 together. So inside my parentheses, I had x and 2, so I multiply those two together, and then I multiply it by 2. That's always going to get me my middle term here. I can always follow the same method that I did above to find these, or I can start to notice some patterns. So now let's look at this example C. So here I'm subtracting, but again I've got two things and I'm squaring it. So I take the first term squared and the second term squared, and then again 2 times the 2 multiplied together will give me my middle term. Okay, so then it just keeps walking us through a couple of them. So I'm going to need to notice the difference of two squares. So if ever I notice that I know the square root of this first one and I know the square root of the second one and I'm subtracting, right, that's difference, I know I'm going to end up with x minus a and x plus a. So the first term minus the second one times the first term plus the second one. I also noticed, and I can go this way as well, so if I have the first term is the same in both and the second term is the same in both and the signs are different, this is what I'm going to end up with. Another common one that we see is squares of binomials or perfect squares. And this is what I was talking about on the previous example. If I'm adding and it's squared, I'm going to have my 2 times my ax as my middle term. If I'm subtracting, it's a negative 2 times ax for my middle term. Okay, so some cubes, so some perfect cubes. So similar to what we were just dealing with, only a few more steps. Okay, you'll see again I have my first term cubed and my second term cubed. Then I have to take my 3ax squared and then 3a squared x. Okay, so and when I'm adding in my original problem, I will add in all places in this last term. So now let's look at when I have a difference of my perfect cubes. The only thing that changes here is this term becomes a negative and this last term becomes a negative. Other than that, I follow my same patterns. So I can also look at the difference of 2 cubes. So here I see a perfect cube and a perfect cube here. I know that if I have that and I'm subtracting my difference of 2 cubes, I end up with x minus a times the quantity x squared plus ax plus a squared. Sometimes this polynomial can then be factored and broken down a little bit more. So I also have the sum of 2 cubes, right? So I still have my perfect cube in both my terms, but I'm adding in the middle here. So I end up with x plus a, and then I have to have a negative sign here to get us to where we really need to go. Other than that, it looks very similar to my difference of 2 cubes. Okay, so all of those examples on the previous few pages, those need to be somewhere where you can get to easily and where you know where they're at. Okay, so now we're going to be dividing some polynomials using long division. So the first thing we want to remember is just actual long division, because we probably haven't done that in quite a while. So the first thing I do is I take my dividend, the thing that I'm dividing, and I take my divisor, what I'm dividing by, which will give me my quotient, right? So I figure out first, how many times does 15 go into 84? And I know that that is 5. 5 times 15 is 75, and then I subtract. I'm left with 9. So then I bring down my 2. How many times does 15 go into 92? 6 times. 6 times 15 is 90, and I subtract, and I have a remainder. So the way that I write my remainder, and I write my problem here, is I've got 842 divided by 15 equals 56 plus my remainder divided by my divisor, what I started with. We're going to be doing this with polynomials. Okay? So find the quotient and remainder when I have 3x cubed plus 4x squared plus x plus 7 when I divide that by x squared plus 1. So let's look at that solution here. So first I want to get it in standard form and make sure it's in standard form. So standard form is where I start with the highest exponent and then work to the smallest. So I've got my dividend and my divisor. So now I only care about this leading term. I only care about this x squared. So I look at this x squared. How many times does x squared go into 3x cubed? Well, I know that x squared times 3x will give me 3x cubed. So now this is going to be up here. So now I multiply that out and enter my results down here. Okay, but I want to keep things in the right order. Okay, so I end up with my 3x cubed. I did not have an x squared term, so I'm going to leave that there. And then I've got my plus 3x. Okay, so as we saw here, I'm going to just subtract now and write down what I have. Well, these two go away. So 4x squared minus 0 is 4x squared. X minus 3x is a negative 2x. And then 7 minus 0 is 7. So now I'm going to continue my steps. And again, I only care about this first term. So how many times does this x squared go into 4x squared? Well, I know if I multiply x squared times 4, I end up with that. So I end up with my 4 up here. I do the same thing again. 4 times x squared gives me 4x squared. 4 times 1 gives me 4. So I multiply that out, and now I subtract, and I end up with this piece right here. Okay, so since I cannot divide x squared into a negative 2x evenly because my exponent is higher up here, I know that we're done and that is going to be my remainder. This down here will be my entire remainder. Since this exponent is smaller than this one, that will be the remainder. So I can rewrite this as 3x plus 4 plus what I had for my remainder, right? That was my remainder, over what I started with. Okay, so now let's look at another one. So find the quotient and remainder when I've got x to the fourth minus 3x cubed plus 2x minus 5 divided by this polynomial. So the first thing I want to do is I want to rewrite it out. But you'll notice here I have to leave a space for that term that I'm missing because I did not have an x squared term. I have to leave it blank and leave a space for it. So again, I just care about this leading term here. So x squared times what gives me x to the fourth? Well, I multiply that by x squared. So now I can multiply this x squared times everything in here. Then I subtract, and I end up with negative 2x cubed minus x squared, and I bring down my 2x and my negative 5. So now, how many times does x squared go into a negative 2x cubed? Well, I know I'm going to have an x and a negative 2. So that's where this comes from. So now I can multiply this 2x times every term here, which will give me this line right here. Then I subtract again and bring down my pieces that I didn't have. So now x squared times what gives me a negative 3x squared? Well, a negative 3. So now I multiply this negative 3 times all of my terms, and that's what's right here in this line. Then again I subtract, and I see that this exponent right here is smaller than my exponent, so I know I'm done. So this is my remainder. Okay, so I can look down and see my final answer is going to be x squared minus 2x minus 3 plus x minus 2 divided by x squared minus x plus 1. Okay. Don't worry about that. So now we're going to look at factoring polynomials, right? There's many ways to do this. So first we want to always factor out any single monomial that we see that's common in all of our terms. So here for this first polynomial, my 2x plus 4, I notice that both of my terms can be divided by 2. So I go and factor that 2 out, and this I'm left with an x plus 2. I can do that with numbers and also with variables. So you see here I have x squared plus x. Well, they both have an x, so I can pull that x out front, and I'm left with the rest. Okay. So some of these should look very familiar to some of the rules that we looked at before. See here I know that this is a difference of cubes because I know the cube root of x cubed and I know the cube root of 1. Here's the difference of squares. So look back at those rules and see if you can follow through some of these examples. Okay, so here's my solutions. So see, this was difference of squares, so I know I'm going to take the first term minus the second term, first plus the second. Okay, so I can work backwards and forwards, and I can continue to go. Since I'm here, I notice I'm not quite completely solved yet, because again here I have the difference of squares again, right here. So I've got an x squared minus 4, that's my difference of squares again, so I can factor that out a little bit more. So here I see I have the difference of cubes, so I can follow my patterns and continue on. This one's a perfect square, so I can just factor that out. So look through these and make sure that you can follow your the rules that we wrote down earlier. Okay, we're looking at completing the square. We're not going to do this a lot right now, we will later on. But what we do is I am trying to find my extra term, my c term, that will make this a perfect square. Because I can easily factor a perfect square, and sometimes these are not so easily factored. Okay, so in order to do that, I always take my middle term, my b term, I divide it by 2 and square it. So I divide it by 2 and square it. So for this example, to complete the square here, I would take this value, my b value, divide it by 2, which is 4, square it, which is 16, which gives me this right here. But you'll notice that when I factor it out, I end up with that 4 when I've divided by 2, goes right there. So same thing here, x squared plus 12x. So this is my b, so I divide it by 2 and square it, which gives me my 36. But when I factor out, I end up with x plus 6 squared. So this is a really handy way to go through and make sure that you can write out the factored form without having to always factor absolutely everything. And I can see how that works using this picture, right? Because I like pictures. So I have y plus 4 quantity squared. So I see here I have y and then 4 and y and then 4. Okay. So if I was to factor that out and I was to multiply that out, I see y times y gives me y squared. This 4 times y is 4y and 4y, and I have to figure out what's left in here to give me this square. That's why I'm doing completing the square, to see what goes in here. So now we're going to look back at our couple learning targets, make sure we met everything. So first we looked at monomials and polynomials. We're going to use these often. And then we looked at some special formulas that are just handy to know. Then I divided polynomials using long division. Coming up soon, we're going to actually be using synthetic division, and it doesn't matter which way. You just need to know how to do this as well. Then we looked at factoring polynomials and a special form of factoring, completing the square. So now that we've gone through all of these learning targets, go ahead and work on your practice problems for this section.